Hello YouTube. This is going to be a bittersweet episode of the study vlog for me because I've had a lot of fun doing this, and I am now at this will be the final episode of the series. So if you're new to the series and you don't know what the heck I'm talking about right now, I am currently a student enrolled at the Flatiron School Data Science Bootcamp. I just completed Phase-3 and I've actually started some of the Phase-4 curriculum right now. 5 phases total. Phase-3 is all about kind of the fundamentals of machine learning. So if you've been keeping up with the series, you should know quite a bit about that by now. Maybe not how to do it, but at least know what the bootcamp will be teaching you. My goal with this vlog series is two things. One is just to I guess 3 things. One is there's a requirement at the end of each phase as part of the program is we're supposed to blog as we go. And so I'm hoping I can get away with doing these vlogs instead of writing, because writing's one of those things where, I kind of have a knack for it, but also don't like to do it at all. I'd much rather do this video format type of thing. Also, my own documentary purposes, I'm interested in growing a YouTube channel seriously one day, but right now all the Flatiron stuff is mostly for me to look back on in 5 years and go, oh wow, look how far I've come, look how much I've learned. And maybe my grandson or somebody can dig it up from the graveyards of the internet one day, and that would be cool, right? Because I can't do that with my granddad. I can't find some YouTube vlog or whatever that he recorded 100 years ago. But hopefully my descendants will be able to do that, so that'll be pretty cool. And also, just for people, the third reason is that I don't necessarily, this isn't supposed to be educational as much as informative. And what I mean by that is this vlog series is not meant to teach you how to do data science or machine learning or anything like that. What this vlog series is meant to do is to give you a very visceral understanding of exactly what a coding bootcamp is like. And doing it self-paced and flex too. I'm not in the 15-week program that's full-time where you're doing 8 or 9 hours of coursework a day after day, 5 to 6 days a week type of thing. I spend probably 6 or 7 hours doing coursework 4 to 5 days out of the week. And I'm taking my time with it, put it that way. But this gives you a good idea of what's covered and exactly what content, what subject matter is covered, and exactly how they delivered the educational materials and all that stuff. Of course, the office hour Zoom calls and that sort of thing are not part of this vlog series. I don't think that would be appropriate to record their stuff for them. But you get the idea enough, or at least what's going on with the boot camp. Yeah, so that's me. That's what this vlog is all about. This is the final episode of Phase-3, and I'll be starting the Phase-4 vlog momentarily, which I have a kind of slightly different idea for how I'm going to format those vlogs, so that should be pretty interesting. Also, if you've been keeping up with this, you'll notice that my background has once again changed. I have moved out of my college apartment, and I am squatting at my parents' place until I finish this program and start working. So I'm in one of the guest bedrooms at the house, as you can see by the trundle bed on the floor there, which is actually for my dog. my bed's off the ground, and that's the dog's bed, the trundle bed that fits underneath it. Yeah, I do have, what I keep looking over here for, though, is I have a second monitor now. It's not really a monitor, it's a television, but I just hooked it up to my computer with an HDMI, and that's been really helpful for, especially when I'm writing code. I have my IDE right here in this computer in front of me, the actual computer, and then I can have the documentation for whatever module I'm working with, or the deliverables for the project I'm working on, or whatever kind of just literature I need. I can have it right there. I can also have cool YouTube videos and stuff playing in the background, which that's not a new thing, but now I can have the actual video on another monitor if I want to quickly look at something instead of having to alt tab through Windows to rewind it whenever I hear them mention something that's cool to me. So yeah, that's 5 minutes of me rambling. So let's go ahead and get started with the vlog. What this episode is going to be is I'm going to be reviewing my milestone project for this phase. Now in phase 2, I actually live streamed while I was doing the project, and that was cool, and I thought about doing that for this phase. Couple reasons I didn't. Main one is that the type of code that I was running is very RAM intensive, and we'll get into like the code itself a little bit later, but basically I was using like 3/4 plus worth of my RAM on my computer, which is not a small amount of RAM to begin with. So to live stream while I'm running those notebooks and running that code could legitimately make my machine crash. So that was one reason I didn't want to live stream it. I guess I could have live streamed on Instagram or something instead, but it was just a lot simpler and more efficient for me to just do the project and then review it later on. So also there was things that had I live streamed them, I would have had to go back and correct anyway, because of course there's always like revisions they want you to make after you submit the project and turn it in, and I'll be mentioning those revisions a little bit as well. So first thing I'm going to do is kind of show you like what the if you're curious about like boot camps in general and don't really care about the project, I'm going to go through Canvas, which is our learning platform that we use at Flatiron, and just show you like what the Canvas page looks like and kind of what the phase overall looks like just the structure of it generally. I'm going to show you, and then we'll get into the project, the data used for the project, and the code that I wrote, and all that good stuff. So we are here now. This is the Flatiron School Canvas page. Let's just go ahead and go to like the page, the dashboard or whatever it's called. Yep, this joint right here. All right, pre-work. This was after you're like accepted and enrolled in the program, paid your deposit and everything. There's some pre-work that they want you. So they want you to be able to write like, a minimum amount of code or whatever. That's what all that is. We're not gonna go into that. Homeroom, I don't think you can probably count on one hand how many times I've actually clicked on that. Most of the like homeroom-esque type stuff we do through Slack. So yeah, so then we have phase 1, 2, 3. Phase 1 was a lot of just like manipulating data with Python and various Python modules, not really like proper data science workflows, but just the kind of underlying technical skills to do the data science kind of work. Phase 2 is where we first started getting into like inklings of machine learning. It was mostly regression analysis, which really threw me for a loop at first. I find it hilarious that the icon for phase 3 is a regression line when all of phase 3 was classification. So if you know anything about ML or statistics, there's a pretty big distinction between regression and classification. So that's funny that there's a regression line for the icon for the classification phase. And this is phase 4. This is the one that I just started. This is going to be more advanced machine learning, like neural networks and natural language processing, unsupervised learning methods, principal component analysis, that sort of thing. So the phase in question is phase 3 here. So in Canvas, you click, and when you first start your phase, I got to give it a second to catch up with me. All this stuff will be locked, and you have to complete a, where'd it go? End of phase survey. So you'll click this. It's a survey for like the previous phase. You fill out a survey about it. Go figure. And that unlocks the rest of the course for you, except for this right here where it says milestone. Whoops. Come on, keep up with it. There we go. This is locked until you can click it correctly. No. Until you get one of these green check marks next to all of the rest. See, my computer's already lagging a little bit just streaming and not running a notebook. It would have been an absolute catastrophe actually running my code while I'm also live streaming. Not a great idea. Yeah, so you have to get these little green check marks next to all the rest of the stuff except the appendices. These are kind of for your own enrichment, which I always like tell myself like, oh, I'm gonna go do that, and then I never do. but I should probably go, and you get like 3 weeks of access to this content after you finish the program. So I definitely need to remember to go through and download the content for each one of these appendices before I get locked out after I do finish, because I would like to go and review it at some point. Be good content to keep you sharp while you're job searching too, and because you want to you don't want to just stop coding at all like once you start job searching. So that's my like last resort for the appendices if I never get to them, is to do them while I'm job searching. And I've like scrolled through them. It's not like a ton of stuff. It wouldn't take a huge amount of time. Yeah, so each one of these modules is basically, so for every vlog, every episode in the Phase 3 series corresponds to one of these topics that you see here. And the bullet points in my vlog notebooks, which is just occurring to me, I don't have one for this, but that's basically the project readme, basically. The bullet points roughly correspond to these like major ideas in each one of these deals. So I don't want to just like blast like Flatiron's content all over the internet, but this stuff's also like, if you just knew where to look, you could find it for free on GitHub. I'm pretty positive. So I'll just go show you a couple examples. So basically, you'll have like some stuff in like a Jupyter notebook, which I have to stay on the page or else it won't load it. So the general pattern is like you have some content, some literature to consume, you have some content to read. Like this is talking about confusion matrices, a very confused matrix. And see, it's not a whole lot. Some of these are in notebooks like this, and others are, let me find one I'm confident about. This is weird to me that every time I reload this page, it unfolds everything and then refolds it. Oh my god. And some of the stuff is like this, where it's just in Canvas and you just scroll through and read it here. I'm not a huge fan of my computer. I have a Surface Book 2. But it is a 2-in-1, so I can split it into like a tablet, and that's really nice for when I have a lot of this stuff to get through. I can just tablet mode it and just like, I like to pace while I read, and so I can just like, hold on. This is not, I'm sorry, this is not reflecting what I'm seeing on my screen here. What the heck? Bro? Oh, it must be in a different window. One second, let me get the right window streaming. There it is. Okay. Yeah, so you have the modules, and then some of them are like this, where it's just text and they have like some cool like images and stuff, and I've used a lot of those images in my vlog notebooks. Sometimes it's like a Jupyter notebook that you scroll through, and they have a this Illumidesk company right here. They have some deal with them where the Illumidesk hosts servers for them specifically to run these like Jupyter notebooks. So I, for my labs, download and run the notebooks locally on my machine, but you don't have to do that. You can use their Illumidesk servers to do that. I just like to have a little bit more manual control over the Git workflow with my stuff. I think it's important for me, like as I'm getting ready for my career, not only to be able to write code and do scientific programming, right, but also to like work in a professional setting, and that means like not necessarily knowing just how to do your job, but get your job to coordinate with like the other people's doing their jobs, right? Which version control in Git is like a major part of that. So that's why I usually just use the Illumidesk servers when I'm reading like the lessons, and then when I'm doing the labs, I'll actually download it to my local repository and run it there, just for the Git practice, like more than anything. And also, I'm just kind of very nitpicky about the way I organize like my directories and files and things on my computers. So that's roughly how Flatiron works, the canvas side of it at least. Give it a second to refold everything. Come on. So once you get through all those modules, which there is a vlog for every single, all 11 or whatever of those up, so you can go back and check that out if you're curious. Then you get into the milestone project. There is one of these for every phase. I've done 3 now so far. So we're just gonna go through these 3 bits right here, maybe the checklist also, and then I'll show you the project itself, the repository for the project. So I took exactly 3 weeks for mine, and I'm supposed to be on the 40-week pace, but that's okay. It's not a hard and fast rule. It's more of a guideline. I'm anticipating finishing around, let's see, it is July 12th right now. I would like to be done like end of August, middle September, somewhere in there. We'll see how that goes. So you have your project requirements, a Jupyter notebook with your technical analysis. I have like 3. A 5 to 10 minute non-technical executive summary presentation, which is a fancy way of saying you're giving a PowerPoint presentation to a make-believe stakeholder for a fictitious company. But it has to be like realistic, right? You can't be like doing analysis on like the, I don't know, like blue milk market in the Star Wars universe or something like that. I'm trying to remember what that blue milk is called, but like you get the idea. You can't be like doing analysis on like the lightsaber market or something. It has to be something legitimate. You need a GitHub repository that contains your IPYMB notebook file, a PDF of the presentation, so not just your presentation itself. You need like a PDF file of the slides for your slide deck presentation, but you also need PDFs of the notebook itself and of your GitHub page. And you also need a README for the repository itself. Getting started, submitting your project on Canvas, all that's really not that interesting or important for the sake of this video. This is weird. They said I went over time on my presentation. It says 5 to 8 minutes here, which makes sense. I was like 9 minutes 17 seconds, but it says like 5 to 10 minutes up there. So that's something I should put in my into Phase survey, which I've already done, but you live and you learn. Yeah, so that's like the overview. And pretty much every milestone project follows that format. You need your technical notebook. You can have multiple if you need to. You need to do a non-technical presentation that uses a slide deck of some sort. Most people use PowerPoint. And you need a well-organized and easy-to-navigate Git repository. And most everybody does uses GitHub, right? Obviously. Project overview. So in phase 1, they gave you the data to deal with, and they gave you the problem to solve with the data, the business use case. For phase 2, they gave you the data, but you had to figure out your own use case. In phase 3, you now have to do both those things. You had to find your own data set to use, and you had to come up with your business use case or your value added. Like, what is the project going to do like for the business? For phase 3 in particular, because I remember I said phase 2 was a regression project, phase 3 was a classification project. So it had to do some sort of classification, solve some sort of classification problem. And if you don't know what I mean by that, go back and watch the rest of this playlist, because I've spent hours now explaining what that is. Iterative approach to modeling. So you can't just build like one model and then call it good. If you know, and if you do build a model on and it's looks like it's good enough on the first try, then there's probably something weird going on. You're probably overfitting if your model is just like really good the first time you build it ever, unless you like already knew something. So and you'll see in a minute that I took a very iterative approach. Your deliverables, again, a non-technical presentation, a Jupyter notebook, and a GitHub repository. So I guess you don't necessarily, it doesn't have to be PowerPoint, or it doesn't even have to be a slide deck, I guess. But I'm not sure how else you would do a presentation without a slide deck type of thing. Blah, 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 the kind of format you have to follow for your non-technical presentation. These are the things that you're being judged on for your notebook. And they give you like rubrics. I'm sure if I asked for it, or maybe I just don't know where to look, but they always like show you like a rubric and, you know, scale 1 to 5 for like each of these things. I've never been like given back a rubric after I've done a project review. It's always just been like pass fail. Maybe if I went to like grades or something, there might be like a rubric in there somewhere I could actually look at how I was graded. But you know, they give you pretty good advice on like what specific things to improve on. And beyond that, it's just pass fail. So like the need for a rubric isn't really there, because they're giving you like specific like actionable, you know, things to improve on. Your GitHub repository, these are the things that your GitHub needs to include. Obviously, you need a README. Grading. It's been a while since I read this. Attention to detail, machine learning communication. So your ability to talk about machine learning concepts in a non-technical way, or in a way that makes sense to non-technical people. Data preparation for machine learning. So your pre-processing, dealing with missing values, one-hot encoding, blah, 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 blah. Non-parametric and ensemble modeling. So by non-parametric, they mean like a decision tree or logistic regression model or something like that, where it's just like the one model. And then ensemble modeling was literally the very last module. And so you go back and look at the very last video, previous video in this playlist, module 31. And that's like random forest, where you use like 10 different decision trees and you take like the aggregate prediction of them, or whatever. So they want you to use both of those, which I did, obviously, because I passed. Attention to detail, blah blah blah. Again, I've never really, I haven't been given like a grade like you made a 85% on this or whatever. It's always just been like, hey, just, you know, fix these few bugs here and then we'll pass you, and you know, that's that. ML communications, this is just going more in depth into all the stuff that's listed above there. You can see that they give you pretty exhaustive descriptions of what's expected of you. Nonetheless, it's still like kind of a game to decipher what to do. So this is just a blurb kind of saying like, hey, you're getting really close to like actually searching for a job, so pick a project that you think would actually be like relevant to the kind of niche that you want to try to enter within the data science world. And that was a problem for me, because I really my degree, if you don't know, is in a foreign language. I have a bachelor's in Spanish language and literature, and had I like known what I knew when I changed my major to that earlier, I probably would have done linguistics and not just like Spanish language. But by that point, I was 25 and I had to finish my degree. Anyway, so natural language processing is the kind of niche that I really want to go into with my data science career. So the problem, there wasn't really any good NLP projects that fit within the kind of bounds of the Phase 3 project. It's likely, however, that there will be some good NLP project ideas that are viable for the Phase 4 project. So I'm looking forward to that. But that was kind of like tough for me to wrestle with because I really wanted to do some like NLP something, you know, like classification could be like just classifying what language like a piece of text is or something like that. Yeah, so that was something that unique to Phase 3 that at this point now, part of the reason they're giving you more freedom in determining like what your project is you should be picking something that's not just like data science related, but like more specific to the type of data science you want to do in your career. And the more I go through the program, the more I realize like there's the world of tech, and then there's the world of data science, and then there's the world within data science, right? So they do give you like some good data sets to work with if you can't find your own. Some other sources to find your own. I looked at the Inside Airbnb one. That was really cool. It's basically this project to their argument is that Airbnb is causing a lot of gentrification in lower income countries, and which makes sense. And so you have a lot of people who can't live in their neighborhood anymore because people are going there to not even live there, but just stay for like a week or two and then leave. It's like, you know, this quaint neighborhood where everybody's living their nice lives is being taken over by people that don't even want to live there anyway. They just want to be there for a couple weeks. So this is a really interesting project. I just didn't really like, it just didn't tickle me, right? But definitely a cool data source I will be like, you know, looking back at in the future. So this is kind of the checklist and rubric thing I was talking about earlier. You know, again, they give you like pretty specific like what's expected of you, right? Data understanding, real world stakeholder, a real problem, real world problem, blah blah blah. Data preparation. And again, all this you can see it's complete or incomplete, but they're pretty specific about like what's considered like complete or incomplete. Your modeling. And that's that. And I think that is, yeah. So this is where you make your project proposal. You can pick one of those data sets they offered, or you can pick your own, which is what I did. This is the link to my data set, which we're going to check out here in a second. And this is where you describe, you have to tell them like what your target feature is going to be and what your general idea is for the project. And they also just need some information about the data set itself, because just because it is data doesn't mean that it is useful for machine learning. You need pretty much at a minimum 1,000 rows of data to do machine learning, and that's if you're starting with, I say at a minimum, like if you only have 1,000 rows, it's likely that you're going to lose 10% of that in pre-processing. So you really need like a good amount. So let's go over here and look at the data set that I used first, which speaking of large data sets, the test alone is like 3 megabytes. This is 12 megabytes, oh my god. Which makes sense why it took so long for my computer to run this code. It's like 104,000 something. Let's go to, yeah, 104,000 rows total. So this is on Kaggle, by the way. If you're not familiar with Kaggle and you're interested in data science, you should definitely get familiar with Kaggle. Just kaggle.com right here. Tons of data sets available on Kaggle. I found this one. This is airline customer satisfaction. So there's some stuff in here that actually has like the details of the flight itself. So like what ticket class they had, was business or economy, that sort of thing. The departure delay. Excuse me. the flight distance, some, like I said, some details about the flight itself, as well as they have most of the features in this data set are, we have some details on the customer themselves too, their gender, their customer type, loyal or disloyal, which is what my target feature was. What I was trying to classify is if somebody's disloyal or not. Their age, where's the survey? Oh, I see. Kaggle's got, yeah, there's like so many features. It was like, oh, we're not going to show you everything. Yeah, so gay location, online boarding, food and drink, like all this stuff. We'll just have to look at a couple of them. These are all categorical, so they're on a scale of 1 to 5. There's some zeros, which were like NA answers. And yeah, so these are all like, how satisfied were you with insert feature label. So that's the data set. One of the things I liked about it was like 104,000 rows, so I had plenty of data. And my target class was, my target feature, the classes were fairly imbalanced. What the class I was trying to predict with the raw data was like 18%, which for classification, you want it like as close to 50% as possible, which I did get it to 50% using smoke resampling. But so there's plenty of data, right? And it was already train test split, which can help with preventing like data leakage and that sort of thing. Data leakage is this idea that depending on how crisp your workflow is, some information from the test sample might leak into the training sample, which would make your model appear to work, be generalizing to the test data a lot better than it actually is. So the fact that it was already split for me into 2 separate CSV files was nice for that reason. So yeah, that's the data set. That's Kaggle. Came with this nice data dictionary, which a lot of like non-professional data sets, which is a lot of what you catch on Kaggle, don't do the diligence to give you a good data dictionary like this. And they did, which that was really cool, which is part of what made me like this data set so much, is there's very specific definitions of like what each feature is and what it means and what's going on there. So that's the data set. I downloaded it and then I started the project. I should have another cup of coffee here pretty soon. So this is my repository for Flatiron broadly and for this project. So I'll just go ahead and show you. When you go to GitHub and you open this particular repository, I have one repository for like all of my Flatiron stuff, right? And that was kind of the brainchild of myself and my first cohort leader. I've had a couple of them now. Because I didn't want to have like, you know, there's probably like 200 or 300 labs you do through the course of this program. I didn't want to have like 200 or 300 different repositories for each lab that I did, which was kind of like the way they taught you to do it when they were teaching you Git early in the program. Again, they kind of like teach you the skills, and they don't necessarily teach you like, they leave it up to you to figure out what's the best way to use those skills for yourself, which is what I did. And so I have this one repository that has like everything in here, except I did set up another repository for my phase 1 project, and when I tried to merge it, I lost it somewhere. So the actual phase 1 project is not in here. RIP. I have the PDFs for it somewhere though, I'm pretty sure. So that's okay. So anyway, you see phase 1, phase 2, phase 3. They all kind of look the same. You have like your modules, and you have project. And go into here. You can see there's really nothing going on here. Just doodling for the project. Yeah. which that's actually interesting. No, come on. Go back. There we go. Go into project. This is not at all like if this is gonna be what I think it's gonna be. This is yeah, okay. So I mentioned earlier I was wanting to do like an NLP type project for it. This is that I found a bunch of these Amazon reviews in different languages. There's 6 different languages total in this data set, and so I wanted to build a model that could classify one language from the other. But it didn't like kind of check all the boxes quite literally for the project requirements, like the way that I was thinking about doing it, so I wasn't able to do that. So that's when I found the airline data set. So I usually like whenever I'm working on something, like I'll branch it and then I'll merge it later on. So if you go back and look at this repo later, like you'll probably want to look under the master branch, and this milestone probably won't exist anymore. So yeah. So this is generally what most of my repositories look like. There's also on my local machine, there's another folder here called presentation with like the PowerPoint and stuff. And sometimes I record like Zoom videos or these kind of videos in there, and that doesn't, GitHub doesn't like large files like that. So I have a git ignore on those folders, so I don't upload like videos and like that sort of thing. Yeah, so most of my project repositories have this general outline. You have like the student IPYNB folder is like the main notebook, which is roughly the same as the README. Obviously the README is like the first thing that you scroll through when you open the page. Review, this is where my PDFs are for all my notebooks and my PowerPoint and the GitHub repository itself. Images, these are like where I save all the different graphs and things that I make like throughout the project, so that I can embed them in like the README and stuff. Or like between notebooks, like I might make a cool plot in one notebook and then I want to reference it in the next notebook, but I don't want to rebuild the whole plot and use like all that code, so I'll just save the PNG file and link it in like a markdown cell. So, how do I want to do this? We got like maybe 20 minutes before I'm gonna call it quits on this. So this is my README. If you go through and read the README, I did my best to kind of tell the story of the project, right? So if you go through and you just read the README, it'll give you a good idea of like kind of what things I did in what order, why I did them, and all that good stuff. So, and all the READMEs for all these projects usually follow the same outline. You want like your business overview, your discussion, you're explaining like exactly what like the project is and what value it provides to the business and why it needs it and blah blah blah. My business case was basically I had all this like data on customer satisfaction, and I noticed that most of the dissatisfied customers were also labeled as disloyal customers. So my big goal was trying to figure out how to identify like what things that disloyal customers are most displeased with that are also the most likely to turn them from disloyal into loyal customers and therefore increase customer retention for the company and increase revenue and like your ability to forecast revenue and like that sort of thing. I made this graphic too, by the way. I play around with graphic design periodically. Not that this is like an incredible, this took me maybe 20 minutes. But I couldn't find a picture of like a plane with like any kind of like data or line plot or anything stuff, which was what I had in mind. So I went on Photopea. If you don't know what Photopea is, it's basically Photoshop for free. So you should check out photopea.com. So I made that. This is reviewing my pre-processing methods, which we'll go into the notebook itself here in a second. But the big thing was I had like some missing values and stuff like that to deal with. Those, what are they called? Survey features had some zeros, but they're on a scale of 1 to 5. So for what I did there was I'm actually going to talk about that when we get to that notebook, because I'm going to want to get in depth on there. Again, these plots are all like embedded from other notebooks, or from the images folder, which were saved from other notebooks. These are my F1 or my ROC receiver operating characteristic curves for the different training models that I built. This blue one was the one I almost went with, but I'll talk about that more in a second. These are my F1 scores by like which model that I built. This is showing, ooh, I need to change that. Right, dark. This is showing the kind of the distribution of features, the weights of the categorical features that are not survey features before and after resampling. The big takeaway here is that the proportions are roughly the same. If you ranked these, they would be roughly the same. Again, this is showing just like that even though there's more total data, because using SMOTE we synthesized more data that didn't originally exist, it still maintains the kind of distribution and weights of these categorical features. This is all the survey, by the way. Again, I'm showing the same thing here. Couple odd-ish things. You get these weird spikes from age, but they still follow the same contour, so I'm not worried about it. Again, for some reason, our original data, our raw data, is much taller here than our resampled data, which is odd to me. But it follows roughly the same shape, so I didn't like really worry about it too much. Again, I'm using a very large data set here, and so this ROC curve, the deeper I got into the project, was not very helpful or telling, but I went ahead and threw it in there anyway. Mainly I was relying on the F1 score to evaluate and select which models to move forward with. One of the things was with this, I had a line plot made that actually had like the model in order of like what iteration it was, and it showed the F1 score like, you know, kind of doing like this and roughly improving. And one of the big revisions they wanted me to make after the review was that a line plot really isn't appropriate for that, because you have like 6 different things. It's not one thing changing over time, which makes sense. I was like, okay, I'll buy that. But when I did this I stacked it. Like I did like this type of thing for this, and it was just like 100% like not as informative to me as like this is. So a lot of the plots, they were like, yeah, we'd like you to change this, but we're not going to not pass you because of it. So I did the more important ones. In a couple of them, I just stood my ground, or like whatever. I was like, this as a line it's way easier for me to read, more informative to me than not. A bunch of scatter plots that are absolutely this belongs on data is ugly. By the way, I wonder if I hope this doesn't break. Okay, yeah, we're gonna zoom out a little bit so we can read this. There's a dead link there that I need to fix. Again, this was probably like my best, like most elegant code that I wrote for a plot, but the plot itself is not very informative. This definitely needs some reworking, because it's not obvious. What I was trying to communicate with this plot is not obvious even to me, what I was trying to communicate with it, but it looks cool. But again, this is all just like visualizing like the different relationships in the data after I selected the final model. Broad stroke strategy was to discover a final model, build it, look at the feature importance from that model, and then use that to kind of guide what areas of the data I zeroed in on, what relationships in the data like I looked at in order to come up with my analysis. Repository structure down here. So to show you how I actually like did this and went about it, I always start with an EDA notebook where I just kind of play around. It's just like a sandbox kind of approach for the EDA. Me kind of summarizing like what's going on in the data, looking at the raw data. I discovered there's some missing values, so I'm dealing with that. And then I kind of like just look at different subsets of features, like just the surveys or just the categorical non-survey features, continuous features, that sort of thing. Again, there's not like a very clear, or like I don't do this exact same way every time, whatever, but there's kind of just like a laundry list of things that I like to go through and like check out. Again, I'm looking at the survey data here. That turned into the much more beautiful plot you saw earlier with like the blue and yellow. One hot encoding. One thing that I had to fix that actually like I had to go and rework a lot of the project after like I had the review. Apparently, it is not acceptable in a professional setting to use pandas, the get dummies function, to do your one hot encoding, because it's something to do with like, say if your test or your training data for like a given feature, if between the train and the test data there's like 6 different features, but for some reason your training data only has 4 of those 6, and then the other 2 like also show up in the test data, pandas isn't going to know that, and you're going to get an error whenever you do your validation like work, right, when you like predict on the test data. So I had to go back, and instead of using pandas, I use pandas a lot, so I was like, oh, I'll just use pandas here because it's somewhat more straightforward how to do your one hot encoding with pandas. That is apparently not a great way to do it, and so I had to go back and rework it to use it with scikit-learn's one hot encoder, which also forced me to turn my target feature into an array instead of a pandas data series into a NumPy array, and flatten it so it's horizontal instead of vertical. And I also learned, and I was honestly kind of frustrated that this wasn't mentioned, as far as I can remember or tell, you don't drop your first column when you're one hot encoding for classification. Right. So for regression, that's one thing that they really like hammered home, was like multicollinearity is a problem with regression analysis, so you have to drop your first column whenever you one hot encode something. Otherwise, you're going to overfit your data. And then as far as I remember, I could be wrong, but as far as I remember going through the curriculum, there was not one mention that you don't have to drop your first column when you're doing classification. In fact, you want to not drop any columns when you're doing classification. So suddenly I had an additional like 5 or 6 features that weren't in the data anymore, and I had to go and rework like all my plots and just like all sorts of like just stuff that just like from the one hot encoding onward, everything was broken and had to be like reworked, which is fine, but as big of a deal as they made that in phase 2 for regression, they should have emphasized that dropping your column is not best practice when you're doing classification. I probably should have like known better than to use pandas and just use scikit-learn anyway. That was kind of me being lazy, so I'll take that one. But not knowing about not dropping the first column, like that should have been made much more they should have made much more of a point of that in the curriculum. That's the only real major like criticism that I have with Phase 3. So this is what I was going to say about the survey data earlier. There's a lot of zeros, but the survey is on a scale of 1 to 5. And so I was like, well, what do I do with these zeros here? I can't just drop all these columns because I'd be losing like way too much, or drop the rows because I'd be losing like a ton of data, which I have a ton of data to let go of anyway, but I don't really want to do that if I don't have to. So my rationale was that if you take all somebody's like answers to like the whole survey, and most of them are like say 3, in terms of like Bayesian probability, it's most likely that their answer to literally any other survey question afterwards will also be 3. So what I did was I wrote this script to go through each row in the data, just the survey data, and if there's a 0 in the row, like any 0 at all in any of their, so each row represents one person. If one person, if they answered 0 to literally any of the survey data for that row, what the script does is it calculates the mode, the most common answer from the rest of their questions, and it replaces the 0 with whatever the mode of that row is. And so that was my rationale, that like and that should still like kind of preserve like the mood and like sentiment of the individual, but also strengthen the model at the same time by not having these like missing values. It didn't eliminate all the zeros entirely. Some rows still had zeros in them, but as best I can tell, that's cases where most of their answers were 0. And if that is the case, then, if I'm sticking consistent with my rationale, then I should just leave that alone. So I did. So that was what the EDA was mostly about, was figuring out what to do with missing values and imputing those zeros and just getting a feel for the data in general. After I went through the EDA notebook, I'm talking slow because I'm waiting for this to work. I also wrote the data dictionary, which is not a requirement of the project, but I kind of think it should be. And what I did here was, oh wow, this is not formatted the way, like this should all be like bullet points. I need to go back and fix that. It shows up like that on the MD file on my computer, but not here. Anyway, this is all not only like the data dictionary from the Kaggle post, but I went back and I included like for the categorical or the binary features, like the class weights for each one. Any like the ordinal categorical features, like I would like write in like what range like they were, or like whatever. The central tendencies, so like the median, mode, mean of like your continuous features, like central tendencies, like scales, like what scale each feature is on, what classes exist in each feature, like all that kind of stuff. Just summary statistic type stuff, which I thought I didn't personally go back and use this a whole lot as I'm going through the project, but it seemed like something that would be nice to have for somebody like looking through the repository wanting to get a abbreviated idea of what's going on, or if there's a particular feature that they were confused about, they can go and look at what's going on with it. So after the EDA notebook, I wrote this Python script with this function data cleaner, and I ended up not actually using this. But data cleaner I use, and this just does all the pre-processing steps that I do in the EDA notebook, like in a single function, and so that way I can import this function and use it in any other notebook that I would use later on. That is something that I do fairly frequently, is write my own modules to use just to make like code like portable between notebooks, so I don't have to rewrite it all the time, or copy and paste and all that stuff. So after the EDA notebook, this is a little out of order. I went and wrote this resampling notebook, which basically what I did here was I suspected that a logistic regression model would be like the weakest model of all the stuff that I've like learned how to do so far. But because of that, it would make it very obvious to me how different resampling strategies affected the data. So what this whole notebook is me building a series of logistic regression models and testing them and looking at like the classification report and all that jazz. You can see all the confusion matrices and everything. So that's all it is. All these logistic regression models, they're all the exact same as far as hyperparameters and all that stuff. The only difference is the resampling strategy used on the data fed into them. So I tried classic SMOTE, SMOTE with edited nearest neighbors, near miss, SMOTE Tomek. Also, I tried all sorts of stuff. And then at the end of the notebook, I looked at the F1 scores. Smotine is what I call it. SMOTE and edited nearest neighbors is the two algorithms that is ensembling. Was the strongest performer overall. The guy that reviewed my project wasn't really like thrilled about it. He was thinking, oh, maybe this is overfitting. I still don't know if I completely agree with that. But the difference in F1 between like the trained Smotine and in the test Smotine, the gap between those two scores is wider than the gap between just classic SMOTE and the test SMOTE. And near miss like performed pretty well too, but it was like near miss was definitely overfitting. So I ended up, at first I did Smotine, and after the review he was like, nah, it's maybe overfitting, and so I went back and changed it to SMOTE. If I had it my way, I wouldn't have done that necessarily. I didn't think it was necessary, but I'm the student, so you know, I try to remain emotionless about like, oh, you need to fix this. Like, you know, it's just like, okay, yeah, I will. You know, not try to be like prideful about like, how dare they not see the genius in my blah blah blah. Because yeah, like, fuck do I know? And I'm plotting like the ROC curves here as well. This is like the train versus test models. So interesting. This is where part of my like disagreement comes from. Smotine worked on the training data literally as well as classic SMOTE did. The only difference was the gap between the train and the test. But the test alone, like SMOTE test versus Smotine test, basically were like the exact same in terms of performance, and so and like the difference and the gaps between the two of them wasn't astronomical anyway. It was like 0.18 and 0.25 or something. But it was there. The difference was there, and so I went ahead and changed it. And they passed my project, and so, you know, go me. This is where I'm like describing the difference in the F1 scores and all that. So originally I chose Smotine. After the review, I went back and reworked everything to be SMOTE instead of Smotine. I can't. I'm trying to like click my roller to like do the thing, and it's not doing that. That's annoying. Oh, there it goes. Oh, I just can't be like on the IC. So after I decided on my resampling method and finalized my pre-processing methods and everything, I went to build my final model. So in this notebook, in the grid searching notebook, I selected a set of different tree-based models that I wanted to explore, which were decision trees, bagging classifiers, which use decision trees. It's an ensemble method of decision trees, and a random forest, which is also an ensemble method of decision trees. And I followed like a similar approach here. I would build a model, but I would grid search it, trying to find the optimal hyperparameters for it. And I would do multiple grid searches and kind of narrowing down like the ranges of my grid searches a little bit more each time until performance would stop improving and start worsening. And then I would pick the grid search with the best performance, and then the grid search from each type of model, the best grid search from each type of model that I did, then I would compare those against each other and chose a final model. You can see me grid searching the bagging classifier here. And then I chose the strongest model of the three with their best grid searches. The only problem was like with the random forest, I didn't actually grid search it. I just manually played around with the hyperparameters a little bit because the random forest, it's like a ton of trees. And it has to grid search like for each one of those trees too, right? And so it was just the computational cost was way too high for my machine. Like I had literally left my computer running like overnight. At one point I woke up and it was still running the cell. It said like, 568 minutes or something ridiculous like that. So I just tried to to manually like play around with the hyperparameters myself a little bit. Nothing that I tried got better than the default hyperparameters for the random forest. And I tried using the best parameters from the random forest is made with decision tree. So I thought, well, maybe I'll use the best parameters from the solo decision tree and that'll help it. Again, it got worse. So, which you can see here, tuned random forest is like slightly better than baseline random forest. These are all on the test data as well. So you can see it's not by much, but the random forest with the default hyperparameters definitely outperformed the rest. Again, like receiver operating characteristic curve. I've never seen it like not. It's with this like acute angle here. It's so much data. I don't know that this is really even like helpful anyway. But it just like I had the code ready to go, so I did it. What is that about? Oh yeah, I keep seeing that error. Okay. It's something to do with like the way I'm doing my X-ticks. So yeah, I don't know. Feature importances. So basically, once I got to here and I picked my final model, this is the feature importance for the final model, and I basically this is like one of the things that I want to like improve on with classification modeling is there has to be like a more like nerdy way to use this information right here. All I really did was go like, oh, business travel is pretty important, so is age, and like I plotted those things and looked at like the relationships with them, right? There has to be like a more robust way and like thorough way to utilize this information here. You can also, you can pickle the model and you can deploy it and use it to like actually make predictions, right? And like I know how to do that. But as far as like guiding my data analysis, I feel there's got to be a better way to do that. But they didn't call me out on it, and it's pretty like clearly explained like how I did what I did. So for the sake of this project, at least, I suppose that it's not really a problem. But that's definitely like a question in my mind. Like, I figure that it just feels like there's something big picture here that I'm missing. But that's basically what I did. I found my final model. I looked at the feature importances of the final model, and then I did my plots based on that, looking at the different like groups and everything. And basically I found that like business travelers between 16 and 39 are the most important people to focus on improving their satisfaction, and the things that they want improved on the most are their actual comfort in flight. So the seat comfort, in-flight Wi-Fi, that sort of thing, food and refreshments, and the online experience. So when they're actually booking their ticket online, when they're checking in online, there's like an online boarding feature, which you can check in on your app instead of going to the desk at the gate. And then, basically like the UX for all that online stuff, they're pretty displeased with, and they would like to be a little bit more comfortable in flight, which makes sense. you know, and all that's like written out here, of course. And after I made that final grid searching notebook, that is when I made the final notebook, and this is the notebook with my technical analysis. I'm recording right now. Okay. So I made this notebook with my final analysis, with my neat little, again, this is also made in Photopea. It's free Photoshop. You should definitely look up Photopea. So I think I showed you this earlier. Pretty sure, yeah. Or the README I did. And this is the technical analysis notebook usually reflects the README pretty similarly. But this notebook, the point of the student.ipynb notebook is more to like actually like give you my technical analysis, and the README is more of an explanation of like what the project is, what it's about, and tell the story of like how the project went. So yeah, this is the first bit of this is me telling the story of like everything I did leading up to this. Class weights, like after, before and after, resampling, again, all the same stuff. You saw that other plot earlier that's similar to this. You can see this is different now because I did the one hot encoding thing and I had way more features to plot, and so here we are. Continuous features. Again, at this point I'm still just like kind of telling the story of everything I've done so far. Now I'm evaluating the performance of the final model, like ensuring that it is in fact representative of the real world, and it's not just really good at like the data that fed into it, but it'll be really good at unseen data that it hasn't been trained on yet. So this is where I get into my interpretation of the model, my business recommendations, which I kind of allude to under each one of these plots here, and then at the end I give like my like more like specific recommendations. Yeah. So after all this is said and done, and I've written my final notebook, then I have a Zoom call scheduled with one of the instructors, and I give them my presentation, which I guess I could show you. Give me a second. This is running a little over. I was wanting to cut off at an hour. This is a little bit over an hour now, but I think it's worth showing the PowerPoint. No. Go back. I thought about making a video of, is this still recording? Oh, okay, cool. Of the, what's it called? My presentation itself. But that's a lot of work, and I want to get into phase 4. But so yeah, you have a Zoom call and you give them your presentation, and I used this slideshow. Obviously, I've been getting really fancy with the animations and all that sort of stuff. Obviously, you want to include some of your visualizations, like from the project, and all like your PowerPoint, your README, like everything kind of follows this like overall format of talk about like the business case, talk about the data itself, and then talk about what you did with the data. Then talk about what you discovered from the data, doing what you did with it. So as you can tell, this is kind of roughly following, again, like the same format. And of course, we've got to plug all my socials and YouTube and everything at the end. And we're going to end slideshow. So that's what that is. After you do make your whole repository and everything, you make a slideshow like this, or some kind of presentation, and you present it. And the first 20 minutes is you do your 5 to 10 minute speech delivering your presentation, and then they spend like 5 to 10 minutes asking you questions as if they were a non-technical stakeholder, and then you spend the rest of the 45-minute meeting of them actually going through your notebook and looking at your code and giving you any kind of bugs to fix or revisions to make and that sort of thing. Excuse me. Yeah, and so like 99% of the time there's gonna be some revisions they want you to make, but usually it'll only take you like an hour or two. For me, I took the whole weekend just because like I could. And you know, you fix those revisions and then they pass you. I've never had to like completely redo my presentation or anything like that. Yeah. So that is it for phase 3 of the Flatiron School study blog. I hope you, I know this isn't, I say learn something, this isn't incredibly educational per se, but if you're curious about coding boot camps and Flatiron School in particular, I hope you learned something about that at least. And you know, hopefully this gives you, the previous study vlogs have been really going into depth on like what I'm learning, but I'm hoping like this video, I spent a lot of time trying to show like exactly like how that learning is facilitated. So I hope I've accomplished that here. As always, if you have any questions, you can contact me, connect with me on LinkedIn. You can and message me there. You can check out the GitHub and explore that if you want to actually look more in depth at the analysis and like that sort of thing. And what else? There's always something else that apply. Oh, Flatiron School itself, right? Obviously, go check out Flatiron School, see everything that it can do for you if you're curious about it. And again, I hope this video, as always, kind of gives you a positive impression of Flatiron School and what it can do for you. So, yeah, we'll see you guys in the next one. It's actually going to be a different playlist after this. We're going to start the Phase 4 playlist, and it'll be a whole nother phase with a whole different sort of season, if you will. So, with that, I hope you have a good day or night, wherever it is, whenever it is, whatever you're doing. And I'll see you in the next study vlog.